When you look up at the night sky, you see a tapestry of stars, each a distant sun shining across unimaginable distances. These tiny points of light have inspired wonder, curiosity, and stories for as long as humans have gazed upward. For millennia, humanity has wondered if we are alone in this vast universe. Ancient civilizations mapped the heavens, searching for meaning in the patterns above, and philosophers pondered the possibility of other worlds and other beings. Earth is our home, a blue marble floating in the cosmic sea, but is it truly the best the cosmos has to offer? Or could there be other worlds, perhaps even more welcoming to life, waiting to be discovered? With telescopes like Kepler and James Webb, we're now searching for signs of life on planets orbiting other stars. These powerful instruments allow us to peer deeper into space than ever before, revealing thousands of exoplanets and expanding our understanding of what's possible. The sheer number of stars, hundreds of billions in our galaxy alone, suggests countless planets, each with its own story. With so many worlds, it seems unlikely that Earth is unique in its ability to support life. This leads us to a bold idea: the superhabitable planet, a world even more suited for life than our own. Scientists now believe that some planets may offer conditions even more favorable for life to thrive. Imagine planets with more stable climates, richer biodiversity, and longer periods for life to evolve. These worlds could have vast forests, endless oceans, and ecosystems more diverse than anything we know on Earth. Exploring these worlds expands our perspective and fuels our curiosity. Each discovery challenges us to rethink what we know about life and what it means to call a planet home. Let's embark on a journey to discover what makes a planet not just habitable, but a true paradise, a place where life could flourish in ways we can only imagine. These worlds challenge our assumptions and invite us to dream of a universe teeming with life, where the possibilities are as endless as the stars themselves. To find worlds better than Earth, we have to start with a cosmic checklist, a set of criteria that helps us identify which planets might be truly special. Astronomers have spent decades refining this list, drawing on everything we know about our own planet, and the conditions that make life possible here. We need to know what makes a planet habitable. It's not just about being the right distance from a star. There are many factors at play, each one crucial for supporting life as we know it. The top ingredient? Liquid water. It's essential for life as we know it, acting as a universal solvent and a medium for biological processes. Without water, life as we understand it simply can't exist. A planet must orbit in the habitable zone, not too hot, not too cold, so water can exist as a liquid. This Goldilocks zone is the sweet spot where temperatures are just right for life to potentially thrive. Too close to its star, water boils away and the planet becomes a scorched wasteland. Too far and water freezes solid, locking any hope for life beneath layers of ice. The planet should be rocky, not a gas giant, because only solid surfaces can support oceans, continents, and the complex chemistry needed for life to develop. And it must have a substantial atmosphere, one thick enough to trap heat, regulate temperature, and shield life from harmful cosmic radiation and solar flares. The atmosphere also provides essential gases for life to breathe, like oxygen or other possible alternatives, depending on the kind of life that might evolve there. Plus, a good atmosphere helps keep water from escaping into space, maintaining the planet's precious supply over billions of years. The type of star matters too. Not all stars are created equal when it comes to nurturing life. Stars smaller and cooler than our Sun, like K-type or M-type dwarfs, live much longer, sometimes for hundreds of billions of years, giving life more time to evolve and adapt. Massive stars, on the other hand, burn out quickly in cosmic terms, exploding as supernovae before life has a real chance to get started. That's why astronomers focus on long-lived, stable stars when searching for habitable worlds, places where life has the time it needs to flourish and diversify. With these criteria in mind, we sift through thousands of exoplanets using powerful telescopes and clever techniques to search for the best candidates, worlds that might even surpass Earth in their potential for life. But what if we could do even better than Earth? What if somewhere out there a planet exists that checks every box and then some? What if Earth isn't the gold standard for life, but just one example? Superhabitable planets could offer even better conditions, more stable climates, richer environments, and longer windows for evolution. Earth has faced ice ages, extinctions, and climate swings. A superhabitable world would be more stable and nurturing. Scientists imagine such a planet orbiting a long-lived, steady star, with features that support abundant life for billions of years. More shallow seas and archipelagos would mean more coastlines, Earth's richest habitats. Out of thousands of exoplanets, a few dozen may fit this superhabitable profile. These aren't just Earth 2.0, they could be something far better. Finding them pushes the boundaries of science and imagination. What would the perfect superhabitable planet look like? It would likely be a super-Earth, about 1.3 times Earth's size and up to twice as massive. Stronger gravity means a thicker atmosphere, better climate regulation, and more protection from radiation. A slightly warmer average temperature, about 5 degrees Celsius higher than Earth's, would eliminate polar ice, creating a temperate, lush world from pole to pole. Instead of vast continents and deep oceans, imagine a planet with shallow seas, lakes, and countless islands, maximizing coastlines and biodiversity. More water in the atmosphere means more clouds and humidity, stabilizing the climate. Sustained geological activity would recycle nutrients and maintain a protective magnetic field. All these factors combine to create a world where life could flourish in ways we can only imagine. Superhabitable planets are nature's ultimate biological powerhouses, and we may have already found some candidates. Before we dive in, smash the like button and subscribe to the channel for more amazing discoveries. Astronomers have already found promising superhabitable candidates. Teegarden b, just 12 light-years away, orbits a calm, long-lived red dwarf. It's similar in mass to Earth and sits in the habitable zone. Its stable environment could support life for billions of years, making it a prime target for future study. Kepler, 1638b, 3,000 light-years away, is a true super-Earth, 1.3 times Earth's size and 4 times as massive. Its strong gravity would help retain a thick protective atmosphere. Kepler, 1638b, orbits a sun-like star in the habitable zone, with a year lasting 259 days. These two worlds show there are many paths to creating a planetary paradise. Each offers unique conditions that could surpass Earth's for supporting life. They're not just data points, they're invitations to imagine new possibilities, and they're only the beginning. LHS 1140b, 49 light-years away, is a rocky planet 40% larger and 7 times more massive than Earth. Its powerful gravity likely means a thick, stable atmosphere, ideal for life. Despite its quick 24-day orbit, it could have comfortable surface temperatures thanks to its greenhouse effect. The TRAPPIST-1 System, 40 light-years away, boasts 7 Earth-sized planets orbiting a cool dwarf star. At least 3, TRAPPIST, 1E, F, and G, are in the habitable zone. These planets may be tidally locked, but thick atmospheres could create temperate twilight zones where life could thrive. One planet has gravity half of Earth's, making it especially intriguing. With so many rocky worlds in one system, TRAPPIST-1 is a prime target for the James Webb Space Telescope. These systems are natural laboratories for studying habitability. They bring us closer to finding life beyond Earth. Some exoplanets feel like distant relatives of Earth. Kepler, 452b, 1,400 light-years away, orbits a sun-like star that's 1.5 billion years older than ours. It's 60% larger than Earth and may have had more time for life to evolve, though its aging star could threaten its habitability. Closer to home, Proxima Centauri b is just 4.2 light-years away, orbiting our nearest stellar neighbor. It's similar in mass to Earth, and sits in the habitable zone, making it a top target for future exploration. However, its star is prone to violent flares, which could strip away its atmosphere and challenge life's survival. Proxima Centauri b may be tidally locked, but a thick atmosphere or ocean could help balance conditions. These worlds remind us that habitability is a delicate balance. Even our closest neighbors hold mysteries and challenges. We've discovered incredible worlds orbiting distant stars, each one a tantalizing mystery waiting to be explored. Yet the vastness of space stretches between us and these alien planets, creating a gulf so immense it's almost impossible to truly comprehend. The distances are not just large, they are staggering, dwarfing anything we experience here on Earth. Even the fastest spacecraft ever launched by humanity would take thousands, if not tens of thousands of years to reach even the nearest exoplanet. Our current technology, impressive as it is, barely scratches the surface of what's needed for true interstellar travel. Take Proxima Centauri b, for example, our closest known exoplanet. It's located 4.2 light-years away, which translates to an astonishing 25 trillion miles. That's a distance so vast it's hard to visualize. With the propulsion systems we have today, a journey to Proxima Centauri b would take over 100,000 years, longer than all of recorded human history. And when we look at even more distant worlds, like Kepler 1638b, the challenge becomes even more daunting. These planets are so far away they are simply unreachable for now, lying far beyond the limits of our current capabilities. These aren't just engineering problems that can be solved with better machines, they're fundamental challenges set by the very laws of physics. The speed of light acts as a cosmic speed limit, making shortcuts impossible with what we know today. The universe is vast and mostly empty, with stars scattered like lonely islands in a dark, endless cosmic ocean. The spaces between them are unimaginably wide and empty. This tyranny of distance is perhaps our greatest obstacle, a barrier that challenges our imagination and our technology alike. For now, we can only study these distant planets from afar, using powerful telescopes and clever techniques to learn about their atmospheres, their climates, and their potential for life. It's a humbling reality, reminding us of our small place in the cosmos. But it also inspires us to dream bigger, to imagine new ways of reaching the stars. The challenge is immense, but so is our drive to explore. Human curiosity has always pushed us to go further, to reach for the unknown. We look up at the stars and wonder what it would take to cross that immense gulf, knowing that one day we might find a way. Faced with these distances, humanity dreams up bold solutions. Concepts like the warp drive, bending space itself remain theoretical but inspire us to think beyond current limits. More practical ideas like laser-powered light sails could send tiny probes to nearby stars at 20% the speed of light. Projects like Breakthrough Starshot aim to reach Proxima Centauri b within a generation. NASA is planning its first interstellar mission, and scientists are exploring advanced propulsion like fusion and antimatter rockets. The journey to the stars will be long, but it's already begun in our imagination. Today, superhabitable worlds are distant points of light. Someday, our descendants may stand on their shores, knowing humanity finally reached the stars.